A mountain 3 times the size of Everest. A storm big enough to engulf our entire planet multiple times. And a moon with more volcanoes than the whole planet itself. These are just a few of the wonders of the solar system. I'm Damon Scotting, and this is Astronomical. Now this one's a mammoth. Okay. If I was to ask you, what's the tallest mountain on Earth? Then you'd probably say Everest. And you'd be right. Everest measures to almost 9 kilometers tall from sea level. But what if I was to ask you, what is the tallest mountain in the solar system? Well, then you could use basic logic to rule out the 4 gas giants, because they can't have mountains, because they have no solid surface and the pressure is far too high for them to venture up, which leaves you with the 4 inner rocky planets: Mercury, Venus, Earth and Mars. Now Mercury's small, bombarded with asteroids constantly, no big mountains. Venus, Earth's hot sister, not so much. Venus has a similar problem to the gas giants. The surface pressure is far too high. Which leaves you with Mars as the only other potential candidate. Now Mars is almost half of Earth's diameter, but that may work as a benefit. Because Mars is a lot smaller, it has a lower surface pressure, allowing things to venture a lot higher from the ground. And indeed, Mars does have the tallest mountain in the solar system. It's called Mount Olympus, and it's 2.5 times taller than Everest. Now, as we know, Everest is the tallest mountain on Earth. It's almost 9 kilometers high, but Mount Olympus is over 21,000 kilometers high. That's 2.5 times larger than Everest. So to put that into perspective for you, if this right here is Everest, then that makes this Mount Olympus.
One of the main differences between the two is that Olympus Mons is a shield volcano, which means it has a very small slope, roughly 5 degrees on average. It's because of this, and Mars' smaller size compared to the Earth, that if you were to stand on the summit of Olympus Mons, you wouldn't even notice you were standing at the top of the solar system's tallest mountain, as its base would extend well beyond the horizon. Its total surface area is slightly more than that of the entire United Kingdom. It is a true wonder of the solar system. Jupiter is the god of the planets. Not only is it the largest in our solar system, it's also home to the biggest storm we've ever seen. This is Jupiter's Great Red Spot. It is an enormous anticyclone which has been allowed to grow to such a size because Jupiter has no landmass, meaning unlike Earth, there's nothing to slow the storm down. Voyager 1 was the first spacecraft to get up close enough to Jupiter to witness the truth about this atmospheric monster. When it was first discovered just over 400 years ago, it was 3 times the size of Earth, a storm big enough to engulf our planet multiple times. But over the past few centuries, the storm has been shrinking and is now only just a bit larger than our planet. We're not sure exactly when it will disappear, but one thing is for certain, that even at its ever-shrinking size, Jupiter's Great Red Spot is still a colossal storm that could swallow our entire planet. Perhaps it is temporary, but for now, it truly is a wonder of the solar system.
So when we talk about the solar system and the planets within it, we split them into 2 categories. The inner rocky planets, Mercury, Venus, Earth and Mars, and then the outer gas giants, Jupiter, Saturn, Uranus and Neptune. Now the inner rocky planets are very close to the Sun. In fact, the furthest one is Mars, and even then at any given point it's still within 2 astronomical units of the Sun. So we'll say that bit of seaweed right there, that's the Sun, not to scale. And then the closest one is Mercury, which is soon followed by Venus. Then we have our planet, planet Earth, And then a bit further out, we have Mars. These are the 4 inner rocky planets. But then Jupiter doesn't come into play until 3 astronomical units later. So Jupiter is all the way out here. So what lies in this great gap? Is there anything at all, or is it like most of space and completely empty? Well, this is where the asteroid belt lies. Now, the asteroid belt is a collection of millions of tiny little pieces of rock, some the size of a particle, others the size of almost 1,000 kilometers. And it stretches all the way around the sun in one complete orbit. Now, if you take all of the asteroids, everything in the asteroid belt itself, and add all its mass up, it still only comes up to half of that of the Earth's moon.
The term asteroid comes from the Greek word asteroides, which means star-like. Even the largest asteroids still can't be resolved through a telescope in the same way a planet can be. Instead, they appear as bright points of light in the sky, like the stars. Within the asteroid belt there are 1.7 million asteroids that are larger than 1 kilometre. But despite there being so many huge rocks, the odds of a collision are less than 1 in a billion. This is because in reality the asteroids are actually really far apart from one another. The asteroid belt is composed of the leftovers from the formation of the solar system when the planets were still coalescing to form the large bodies we know today. There is not enough mass in the entire asteroid belt to form a small terrestrial planet. And even if there were, it still would be very difficult to do so, since Jupiter's gravity prevents the asteroids from forming a much larger body the size of a planet.
So the majority of these are tiny. In fact, the biggest object in it is called Ceres. Now, Ceres is a dwarf planet. It's still less than 1,000 kilometers in diameter, which means it's smaller than the moon.
Ceres is the most water-rich body in the inner solar system other than the Earth. We still know very little about the asteroid belt. Some theories about the evolution of life base themselves on the idea that it started here on Earth thanks to an impact from an asteroid that contained the ingredients for life. So perhaps there are still wonders waiting to be discovered within the asteroid belt.
Now, Jupiter, as well as being the largest planet in our solar system, also has the most amount of moons. In fact, the current total of moons orbiting Jupiter is 72. However, we're going to look at 4 in particular, Jupiter's Galilean moons. Now, these moons were discovered in the 1600s by Galileo himself. They were seen as 4 bright points of light orbiting around the planet at regular intervals. They're known as Ganymede, Io, Callisto, and Europa. Ganymede is the largest of these moons, and it's also the largest moon in the entire solar system. So big, in fact, it's bigger than the planet Mercury.
Ganymede is far larger than our own moon, and in terms of volume, it could fit exactly 12 of the dwarf planet Pluto inside of it. If it wasn't orbiting Jupiter, but instead the Sun at the same distance as any of the inner rocky planets, then it would easily fall under the classification of a planet. Then we have Io. Now, Io is the most volcanic world in our solar system. There are more volcanoes on the surface of Io than there are on the whole of planet Earth. Io is a hellish world. Upon its surface lie countless scars. It is the innermost of the Galilean moons, which means it is a tortured world. It's in the middle of a tug of war from Jupiter and the other more distant moons. Like most bodies, its orbit is slightly eccentric, which means it's not a perfect circle. Instead, it's more like a squash circle, which leads to points in its orbit where it feels a stronger gravitational pull from Jupiter, and points where it feels less. This causes the moon to contract and expand in a process known as tidal heating. The moon's crust is constantly being broken, leading to cracks appearing and volcanoes forming on its surface. When the first images came in of Io, scientists weren't certain what to expect. In this photo, many assumed that there was another moon behind Io in the distance. but it was only when an engineer pointed out that this was no moon. It was a volcanic plume. The volcanoes on Io's surface were active. Intense lava flows across the surface of Io. A truly bizarre world.
Then we have Europa. Now Europa's surface is frozen, but beneath it lies oceans of liquid. In fact, there's more liquid on the moon Europa than there is on the whole of planet Earth.
Europa is classed as one of our best chances of finding life elsewhere in the solar system. It has a frozen surface, but trapped beneath it there are oceans of liquid water, more than on the whole of Earth. Europa has an even more eccentric orbit than Io. The constant stretching and relaxing of the moon causes geysers to erupt from the surface, firing ice particles high up into the atmosphere.
And then lastly we have Callisto, the second largest of the Galilean moons, mostly featureless.
Callisto is almost the exact same size as the planet Mercury, but it only has 1/3 of the mass. It is the most distant of the Galilean moons, and its heavily cratered surface is one of the oldest landscapes in the solar system. The Galilean moons are each more different than the last. They collectively have a vast number of curiosities that have left scientists very eager to explore these wonders in more detail. Saturn's rings are in their own right a wonder of the solar system. They are made up of billions of fragments of ice and rock, which encircle Saturn with an enormous diameter of 280,000 kilometers, more than twice the planet's diameter. But even more astonishing is their thickness, on average, is just 10 meters. However, the real wonder isn't one of Saturn's rings. It's what lies buried in Saturn's most outer ring. In recent decades, discoveries about this wonder have made it the most intriguing world in the entire solar system. This is Enceladus. Enceladus is a fresh moon. It is only 500 kilometers in diameter, but is the most reflective body in our solar system, reflecting 90% of the light. Beneath the surface of ice lies oceans of liquid. At the bottom of these oceans are hydrothermal vents. The temperature difference between the cold surface and the warm core causes cracks to appear and geysers form. Hot jets of ice erupt from the moon's surface. Now on Earth we also have geysers, but here they only erupt to heights of 20 meters. On Enceladus, where the surface gravity is far less, the plumes of ice reach heights of 1,000 kilometers. Most of the ice particles escape the moon's gravity, whilst any that don't fall back onto the moon and resurface it, making Enceladus fresh and reflective. As the moon orbits around Saturn, it leaves a trail of ice, forming Saturn's E-ring. Life on Earth is currently believed to have started at the bottom of the oceans from hydrothermal vents. They produce the ingredients and environment necessary for life. So beneath Enceladus's fresh, frozen surface, there may be life. It could be truly alien life, species that we've never seen anything like, or simple life, single-celled organisms. For decades we've seen Mars as our best chance of life elsewhere in the solar system. But the truth is, life may be found first beneath the surface of the moon orbiting a gas giant. This is Saturn's largest moon, Titan. It is a hazy world with a thick blue atmosphere, making it very similar to the Earth, meaning it has a strong potential for life. But it's very hard to see what the surface of Titan looks like. So in 2005, we sent the Huygens probe to land on the moon and reveal its secrets. Hidden beneath a dense haze lies a solid surface. At temperatures of minus 179 degrees Celsius, most of it is frozen, but not all of it. The Cassini probe orbiting around the moon detected lakes on the moon's surface. But a temperature is far too cold for liquid water to exist, so what is it? This is real footage from when the Huygens probe landed on the surface of Titan. In doing so, it became the most distant probe to ever attempt a landing on another world. Once the Huygens probe reached the surface, it saw rocks that had been eroded in the same way rocks here on Earth are by bodies of water. The lakes on Titan are filled with liquid methane. There is potential for life to exist within the lakes of liquid methane on Titan, in the same way that organisms here on Earth live in water. It is possible that as the sun swells in its later stages of life, and it begins to heat the rest of the solar system, temperatures on Titan could reach levels that would allow liquid water to exist on its surface. The period in which this may happen could be several 100 million years, meaning there is plenty of time for life to form. Maybe, if we can manipulate the atmosphere to make it similar enough to here on Earth, it could become a potential second home once our planet is no longer habitable. This is the most distant man-made object ever. The Voyager 1 spacecraft was launched September 1977, just 16 days after its twin, Voyager 2. Their goal was to take advantage of a rare planetary alignment between the gas giants. Voyager 2 would take a slightly different trajectory in order to visit all four of the gas giants, whereas Voyager 1 was only heading for Jupiter and Saturn before the next part of its mission began. They each carried one of mankind's greatest ever collections. This is the Golden Record. On it are a number of images, songs and other sounds from here on Earth. The record also has a set of instructions that will only be understood by intelligent life. Directions on how to play the record, where the record came from, and what the first image on it should look like. The music and sounds are from all across our planet. It features greetings from the people of Earth in 55 different languages.
Hola y saludos a todos.
Tanti auguri e saluti.
我做生的小蘑菇。
有空请到这儿来玩。
Здравствуйте, приветствую вас.
Bonjour tout le monde. Konnichiwa.
Hello from the children of planet Earth.
Voyager gave us images of the planets that we could never have achieved here on Earth. It then set off towards Saturn. Imaging the planet, its rings, and several of its moons, including the blue atmosphere of the hazy giant, Titan. For Voyager 1, this was the end of its mission to explore the gas giants, but its final mission had just begun. After gaining speed from its orbit around Saturn, it set off into the very edge of the solar system, heading where no probe had ever been before. But before it begins shutting each of its systems down one by one, Voyager was instructed to do one last task: to turn back towards the solar system and take a final image. It produced arguably one of the most powerful photos in the history of mankind. This is the pale blue dot. It may look insignificant, but this faint, fragile point of light is our home. On it is every single human being to ever live. The entirety of our delicate species have all coexisted for only a few cosmic seconds on this pale blue dot. We may be alone in the universe. There may not be any other worlds out there that are capable of supporting life quite like our own, making this speck of dust suspended in a sunbeam the most precious thing in our universe. These spacecraft have only pure intentions, to inform others of our desire to explore in our quest for knowledge. Voyager won't find intelligent life. It will need to be found by intelligent life. As it leaves our solar system and sets off into interstellar space, it is alone, adrift in the vast cosmic sea, carrying the hopes and dreams of our entire civilization.
By 2025, Voyager will have run out of power. But the record on board will likely last 10 billion years. It will outlive our entire solar system. So if we don't manage to make it off our planet, if our civilization doesn't colonize another world, and we are doomed to die in our solar system and never visit other stars, then at least we have this. At least we have evidence of what we once were. There's a popular theory that the reason we haven't seen other alien civilizations is because civilizations themselves don't exist long enough to interact with one another. And if that's the case and we are doomed to destroy ourselves, then there's still hope. There's still hope that one day an alien civilization will come across Voyager and they'll see all the records of what we once were. And for me, that is why Voyager was the wonder of our solar system. I'm Damon Scotting, and this was Astronomical.
As the Secretary General of the United Nations, an organization of 147 member states who represent almost all of the human inhabitants of the planet Earth, I send greetings on behalf of the people of our planet.
Hello from the children of planet Earth.
About the planets, we split them up into two categories. You have the inner rocky giants. Nah, f it. F that one. Okay. 3, 2, 1. 3, 2, 1. Mountains. Times bigger than Everest. A storm big enough to engulf our world multiple times. And a moon with more volcanoes than the whole of Earth. These are just a few of the Ninu Ninus. That's what I get for filming in London. Now, on Mars,